Hello all, welcome to the subject of the microcontroller. I am Professor Meenakshi Panja from Electronics and Telecommunication Department, Parvatibai Gyanba, Mojay College of Engineering, Wagoli, Pune. In a previous lecture, we have learned about the data acquisition system. We have seen all the operation of each blocks. So, in today's lecture, we will see instrument used for measuring the temperature. So what are these instruments and why we have to measure the temperature? See here, this is data acquisition system which is having, this is nothing but it's a system. What it will do, it's input data like a temperature, humidity, flow. So that data, if we directly feed to our microcontroller or computer, which is not understand, which it cannot be processed on that. So what we have to do before we have to apply these data, it will understand only the digit 0 and 1. So those language which is only understanding here. So that's why what we have to do, we have to first convert this pressure, humidity and flow, whatever the data, into that form that the microcontroller and computer can easily understand. So for that we are using the sensor transducer. So the sensor transducer, what it will do, which converts the physical parameters. So these are the physical parameter which convert these physical parameter into the electrical signals. And the physical parameter includes the pressure, temperature, humidity, and all that. Then after the after that electrical signal, that is applied to this signal conditioner. So in the signal conditional, this is one of the block which is used to produce the conditions so that the circuit can work properly. So this is one of the block which is used for controlling the signal conditions. So on that the microcontroller can work easily. After that, whatever the uh, output which comes from the signal condition, we are directly applying to this analog to digital converter. Here what will happen, this converts the analog voltage into the equivalent digital equivalent signals, digital equivalent data, and it may contain the multiplexer and accept the multiple input. We have already seen what is the infrastructure of analog to digital converter in a previous lectures. So which is having multiplexer and multiple input is sequentially connected them to the converter. So that facility which is having involved in itself. So after that, the output of this analog to digital converter, which is directly we can apply to this microcontroller. So while doing such operation, there may be a temperature may be vary. The temperature may be vary. So measuring that temperature, we are using some instrument. So let's see one by one what instrument we are using. First of all, the temperature measuring instrument, which requires one of the following elements. That element is called thermocouples, resistance temperature detector, and negative temperature coefficient. So these things, first of all, we have to require. What are the things required? What are the things required for us for measuring the temperature? First one is thermocouple. First one is thermocouple. Second one is RTD, is nothing but resistance temperature detector, and another one is, I will write in a short form, NTC, which is means negative temperature coefficient, or we can say positive temperature coefficient. So these things required for, these are the elements which is required for measuring the temperature. First, let's see one by one. What is the thermocouple? The thermocouple contains a two wire of the dissimilar metal, and one junction is at the temperature to be measured and the other is referred as a temperature. So that surrounds the room temperature or ice temperature, which is 0 degrees Celsius. This figure shows this thermocouple. Here this figure shows what it will, in this figure, see the thermocouple they have used here, thermocouple. In the thermocouple, they contains two wires. So two wires, they are similar metals. So they are not in similar. Two wires are not in a similar. So one junction is that at the temperature. So there is one junction is there. So that is used for measuring the reference temperature and with the measuring the temperature with the reference temperature. Here reference temperature is nothing but that surrounded the room temperature, or we can say 0 degrees Celsius ice temperature. So this is the thermocouple. Second one is resistance temperature detector. This means like a platinum resistor temperature detector, resistance changes about 0.4 ohm per degree Celsius for 100 ohm at 0 degree Celsius unit. The negative temperature coefficient or positive temperature coefficient are linearized thermistors. So here shown in a figure, second figure, this figure. So this is which is having the prototype instrument for PTC and NTC based temperature measurement using the MCU, and the IC based semiconductor temperature sensor, for example AD590 from the analog device, which is shown in this third figure, shows as a prototype instrument for measuring the temperature using the microcontroller. So instrument for measuring the current using a current sensor, a current passing through semiconductor in a surrounding of the perpendicular magnetic field, which generates a voltage that can be measured by an appropriate Hall sensor. A Hall sensor measures a voltage across the semiconductor, for example bismuth, and the voltage V developed along the x-axis, which is proportional to the current I along the y-axis when the magnetic field H appears along the x-axis. The instrument for measuring the voltage using voltage sensor thermistor. Here the voltage sensing thermistor can be used for measuring the DC or AC peak voltage.